Hello everyone, so today we are going to solve another interesting problem number 18 for sum. And the problem says we have been given an array nums of any integer, written an array of all unique quadruplets nums a, b, c and d such that a and b, c and d are within 0 to n, where a, b, c and d are distinct, and nums of a plus b plus c plus d is equals to target, and we may return the answer in any order. Okay, so the algorithm which I'm going to show you solve any kind of problem for 4 sum, 5 sum or n sum such that you can handle everything on every one of them very easily. So what we'll do is, so for the first thing what we'll do is we'll sort the given array that we have. So if I sort the original array nums, this becomes minus 2, minus 1, 0, 0 and 1 and 2. Now what we'll do is we'll just pick two pointers I and j will start from I plus 1, and now in the remaining region that we have, since this is a sorted a region, here we can apply here we can apply binary search to look for two more uh, integers such that they sums up to these required sum that we are looking for. So now we have fixed the initial two pointers, and now we are looking for the another two which makes our sum such that it reaches to the target. So our sum would be s is equals to nums of I plus nums of j, and now the other two numbers that we are looking for are nums of l and r. And how I'm sure this is working, so this is the sorted array that we are in which we are, and we are looking for these two numbers l, and the l is starting from after j plus 1, and r will keep at the end of the array. And what we'll do is we'll look for the target. So the s, this portion of the sum is constant, and we are only varying these two numbers. So if my sum becomes greater than the target, then I'm sure that we need to decrement our sum. So we'll update our right pointer towards the left, and if we find any sum that is less than the target, then we are sure that we need to update our left pointer over the right, and in the end we'll reach to a region where we'll have 2 points L and R such that this sum becomes equals to target that we are in. So using this algorithm we'll find these two other pointers, and with the binary search condition that we have in our hand. So now what we'll do is I'm going to demonstrate you the another two solution that we're looking for. The first two pointers, so for the first number 2 are minus 2, minus 1, and the another two numbers which makes our sum equals to the target is 1 and 2. Similarly, when we'll update our these two pointers in the iteration, we'll move this I towards the right, towards the end, and j with one step ahead of I. Now we'll again look for the number uh, minus we are looking for now another two numbers which makes our sum equals to 0. So that would be, so here I will create one set to store my answer. The use of set is it only contains unique element. So in set I'm creating tuples to find our solutions. So that would be minus 1, minus 0. These are the fixed initial two numbers that I have fixed, and I'm looking for two more numbers that make my sum equals to 0. Probably I will do for when I will fix I at 2 and j will start from 0. So then also we'll find these another two numbers 0 and 0 and 2, that will make our sum equals to target. So, and in the end we'll just iterate this set of our answer solution and will return the uh, list from the tuple that we want to return. So now let's get into the coding part, where I'm going to show you how to write this algorithm in the manner that I discussed. So the first thing that we need is we need to declare one set. So this answer is the set that I'm going to keep track of the unique quadruplets, and then in the n variable I will have the length of the original list, and the for this algorithm will first sort our original array. So I like to do nums equals to sorted nums. I will use the sorted inbuilt function from the Python library that returns the array sorted, and nums.sort do not return the original array. It just update the original array at its place. So now we'll find, so first we'll pick one number until the range n, and then we'll pick another number from starting from I plus 1 and go till the end. And now we'll place two pointer and r at in the remaining region where we want to find our sum that is reaching to the target. And now we'll apply the modified binary search version, and we'll check what are some values. So first we'll calculate sum. So for that we need sum. We'll calculate sum by adding all the four numbers together at positions of the pointers, and now we'll check the value of the sum with the target. So if s is equals to target, then we need to do something with our answer, and else if my sum is more than the target, then I'm sure that I need to decrement my sum variable. So for that I will update the right pointer towards the left, otherwise I'm going to update the left pointer when my sum is less than the target. So now once we have reached when s equals to target, so this is the our triplet that we want to store. So what we'll do is we'll store this into our set that we have created, nums of j, nums of L, and nums of R. These are the four numbers that we are looking for, and now we'll update both left and right pointers toward in between. So we'll update left pointer toward the right and right pointer toward the left to shorten our search region to find for any other number. So if I show you the answer set right now, in which we have the answer in the form of set of tuple. So we have our answers, and all we just need to do is convert this set of tuples into list of lists. So for that, what I will do is I will simply traverse in the set that we have created, and I will return the list of the tuple that we have created to look for our solutions. And now we'll run our code and submit our solution and see how it performs. So it has been accepted. Now let's run it for different test cases. That has been accepted for all the test cases, and let's submit our solution and see how it performs for all the test case solutions. So it has been accepted, and this algorithm you can extend it for any kind of sum that you want to find. So the time complexity, coming to the time complexity is O of n cube, and the space complexity is O of the size of the set that I have created, answer set. So how many the number of unique quadruplet that found, that will be the phase complexity. So this would be the solution for foursome, and I hope you guys are liking my solution. If you have any particular problem that you want me to solve, please let me know, and keep I will solve another algorithmic problem, and I will keep bringing such more awesome algorithmic solutions for you. Please like and subscribe to the channel. It helps the channel to grow and bring and help and motivate me in bringing more such awesome content for you guys. Thank you and have a nice day.